This video is to go over homework 2C lesson 2.10. The first question says, in the figure below, triangle ABC is an isosceles triangle with AC is congruent to segment BC. CD is a median of triangle ABC and segment CE bisects triangle ACD. And also CF bisects angle BCD. Which of the following is a correct way to prove that triangle ACE is congruent to BCF? So first of all, we can put the tick mark for AC and CB because they're isosceles triangle and they're congruent. And CD is a median, that means D is a midpoint. And also CE bisects angle ACD, so these two angles are the same. And also CF bisects that angle, so these two angles are the same. So putting these tick marks probably help you to find more, find out find out the reason. So we want to prove triangle ACE is congruent to BCF. And so if we can make a reverse list, we're gonna prove that these two triangles are congruent, and we already have SA right there. We have SA, right? So first we have to prove. We also know that angle A and angle B is congruent because it's isosceles triangle, because of the isosceles theorem, triangle theorem. But we don't know these two angles are. Angle ECD is congruent to angle FCD, so we can really use these ACE and VCF. Those two angles are not really, we can't tell they're the same, so we have to figure out some other things. So here's the hint: if you prove triangle CED and triangle CFD, so those two triangles in the middle, if we can prove these two triangles are congruent, then we can tell CE is congruent to CF, right? Then we can start from there. So I would suggest to prove triangle CD is congruent to CDF first, and then use the by CPCTC, C is congruent to CF, so that we can have another one of triplets. So that's the hint. And let's move on to problem number 6. Problem 6. Draw an isosceles triangle and the bisector of its vertex angle. Prove that the two smaller triangles formed are congruent. So problem number 6, let's draw a diagram. So that's the first thing we want to do. Draw isosceles triangle. Let's say ABC. A is on top and B is on the left side and C is on the right side. And since it's isosceles triangle, AB is congruent to AC, and also angle B and angle C are congruent. Now we know that by just saying isosceles triangle, so make sure you put the tick mark like that. And then the bisector of its vertex angle. So if you bisect angle A, angle B, angle C, like that, then we got to prove that small triangle, let's say the concurrence point P, and let's say the intersection of angle bisector of A to B, let's call it D. So the angle triangle BPD is congruent to CPD. But why? It looks like it, but why is that? So find the triplets to prove that. Problem number 7. In triangle XYM XE is a median, so M is a midpoint, in other words. And segment XY is congruent to segment XM. The bulleted list below is a sketch of a proof that triangle XEM is congruent to triangle XEY. Study the list, then write the proof in either two-column paragraph or outline style. So we have four bulleted list. Segment XE is a median, so E is, that's E. Segment XE is a median, so E is the midpoint of segment MY, then ME is congruent to EY. So you can put some tick mark. And segment XY is congruent to segment XM, which is given. The two triangles share XE, segment XE. The triangle have the three pairs of congruent sides. So obviously, the triplets that we can that guarantee these two triangles are congruent is SSS. However, so write the proof. Problem number 8. What's wrong here? Below is a proof that shows that any two lines are parallel. Explain what's wrong with the proof. So problem number 8. We have some line. Doesn't look like parallel, but we have line EF on top and line GH on the bottom, and the intersection of transversal and EF is L, and the intersection of transversal of line GH is M. So suppose line EF and line GH are lines, so that means it's straight. Draw transversal line LM, which is already wrote, because angle ELM and angle HML are alternate interior angles. So ELM and HML are alternate interior angle. Therefore, ELM is congruent to HML. Therefore, EF is line EF is parallel to line GH. So this is the proof, but there is something wrong here. I don't want you to look at the diagram, but I want you to look at the proof, and there is something wrong here. So what is that? In the figure at the right. We have this figure. In the figure at the right, AB is parallel to, oops, not that one. AB is parallel to ED. We use that kind of tick mark to say it's parallel. And segment AB is congruent to segment ED. Typically use this information to prove that triangle ABF is congruent to DEF. Explain why is his paragraph proof is incorrect. So he said it is given that line AB is parallel to line ED. So angle DEB, which is this one, is congruent to ABE, because parallel lines form congruent to alternate interior angles with a transversal, and angle AFB is congruent to DFE because they are vertical angles, and vertical angles are congruent. It is also given that segment AB is congruent to ED, therefore triangle ABF is congruent to DEF by ASA. So there is something wrong with this proof, so I want you to look into that. B, is it possible to prove that those two triangles are congruent? If so, write the correct proof. And problem number 10, to show that the statement is true, mathematicians require deductive proof. Explain how you can convince someone that the statement all hoses are the same color is not true. how can you show that that is actually wrong or false? That's problem 10. Problem 11, use circle P used to prove that three angles are congruent. Point P is the center of the circle. So we have that. We have circle, we have that's terrible. Well, you got the figure in your paper. So why these three angles are congruent, and P is the center of the circle. Don't say it looks like it.